We're going to look at some applications. It says an athlete ran for part of an hour at 6 miles per hour and the rest of the hour at 8 miles per hour. That's important that it says the hour, so it looks like the athlete ran for an hour total. And the total distance traveled was 7 miles. So this is the D equals RT formula. So I'll call it part 1 and maybe part 2 of his trip. He ran at 6 miles per hour, and then for the rest of the hour he ran at 8 miles per hour. Those are the clear pieces of info, the two speeds, 6 miles per hour, 8 miles per hour. The total distance traveled was 7 miles per hour. How long did the athlete run at each speed? So since it says how long, I'm going to say let x be equal to part 1's time, and let's say y equal to part 2's time. So how long he spent running in the first part of the trip and how long he spent running in the second part of the trip. I'm not going to overthink it, I'm just going to call it x and y, since now we know to use two equations and two unknowns if we want to. Now if I have the rate and the time, I can multiply those two guys to fill the distance box. Multiply those two guys to fill the distance box. So I knew these as a fact. These two guys I didn't know, I gave them my own variables, and the distance box I filled out using these pieces of info. Now here's the other important information again to watch out for. They say it's for the rest of the hour, it was at 8 miles per hour. This automatically means that the total time was 1 hour. And also it says that the total distance traveled was 7 miles. So they give us two totals. Total time is 1 hour, total distance is 7 miles, and with that information I can get two equations. Total time, 1 hour, and also total distance, 7 miles. So I should be able to come up with two equations. Remember, if I have two unknowns, I better have two equations. Equation 1 is the total time equation, x plus y is equal to 1 hour. And equation 2, 6x plus 8y equals 7 miles, is the distance equation. Then I can go solving this whatever method I want. Let's say I want to do substitution, so I'm going to get the y by itself quickly. I move the x to the other side by subtracting x from both sides. I'm going to take this guy and plug it in place of the y in the second equation. So that's 6x plus 8, plug in a minus x plus 1 for the y equals 7. Having solved that, we get x equal to 1/2, and now I can go find y, maybe using the first equation because it's simpler. So if I plug in a half for my x and subtract a half from both sides, I get 1 minus 1/2, which is also a half. So now I go back and I respond to what I was supposed to find. I've gone on and said first part of the trip was half hour at 6 miles per hour, and then second part of the trip was also half hour at 8 miles per hour, because we were supposed to find how long he ran at each speed. Half hour at 6 miles per hour, half hour at 8 miles per hour. Example 2, same kind of problem. It's a distance and a time problem, so I'm going to fill my chart and then fill the pieces, or draw my chart and fill the pieces accordingly. A car was driven for 2 hours, part of the time at 40 miles per hour and the rest of the time at 60 miles per hour. So part 1, part 2, let's say, 40 miles per hour and then faster at 60 miles per hour. The total distance was 90 miles. That's something to pay attention to. I'm going to use that later. How long did the car travel at each speed? Well, how long again asks us for the time, so I'm going to call it x at this speed, y at that speed. So x, we'll say time for 40 miles per hour, or part 1, and y is the time for 60 miles per hour, or part 2 in our case. Again, I have the rate and the time, I get 40x, the rate and the time, I get 60y. And I have the total distance, so there's one equation. Total distance is 9 miles. I also have this other piece of info. It says the car was driven for 2 hours. Part was at one speed, the other part was at the other speed. In other words, the total time is given to us to be 4 hours, or 2 hours, I'm sorry. So there's my other equation. I have one equation for the time, x plus y is 2, and the other equation for the distance, 40x plus 60y is equal to, so y equal to 1/2, and I'm going to go plug it in. We just solved by the elimination method again to get rid of the x's. I wanted the coefficients to match up. So y is equal to 1/2 and or 0.5. So subtracting 0.5 from both sides give us 1.5. And then I'll go answer the question based on what it was saying. So it looks like it is going to be going at 40 miles per hour for 1.5 hours and at 60 miles per hour at half an hour. Y was half an hour and it stood for the faster speed, and x was the 1.5 hours and it stood for the time for the slower speed. Okay, this is another distance equals rate times time problem. It's talking about a boat traveling, so let's make our chart and relate the information. It says a boat travels downstream at 50 miles, downstream 50 miles, that's a distance, in 5 hours. So there's going to be a boat going down. The return trip takes 7 hours and 30 minutes. So I guess if it goes down, then it's going to come back up, let's say. Find the speed of the boat without a current and the speed of the current. So let's fill in the info we know. The boat goes down and the mileage is 150 miles and the time is 5 hours. Then the boat comes back up. They don't tell us, but I have to assume that it comes back up the same way, so distance is 150. The time this time is 7.5 hours. I can't put it in minutes, everything is in miles an hour, so I'm going to put that as 7.5 hours for the time. We need to find two things: the speed of the boat without a current and the speed of the current. So I'll say x is speed of boat all by itself, and then I'll say y is speed of the current. So when it comes down, when the boat goes down, it's going faster because the current is helping it. So the speed, we can either divide 5 into 150 and get a number and then work with our variables, or we can just go ahead and put them right here, right now. When it goes down, it goes faster, so the boat and the current help each other out. The speed actually is faster by y miles per hour. When the boat comes up, if it goes the other way, it's actually going to be slower because this current is going to try to stop it and slow it down, so it'll be the boat minus the current. So down is always boat plus the current speed, and up is always boat minus the current speed. It would be the same type of problem if a plane was traveling with wind or against the wind. Now I have my two equations. I have 5 times x plus y is 150, and also 7 times x minus y is 150. Then I solve this system. This was actually a 7.5 for the time, not 7. So instead of distributing, I'm just going to divide both sides by 5 to get rid of this 5, and instead of distributing, again, I'm going to divide both sides by 7.5. So when I divide by 5, I get x plus y equals 30, x minus y equals 20, get rid of the y's, and I get x equals 25. Now I'm going to go back into this one and find the y value. So once I plug the 25 back into here, I isolate y and I get y equals 5. So x was 25 miles per hour, that's the speed of the boat, and y is 5 miles per hour, the speed of the current. Student takes out 2 loans totaling $4,000 to help pay for college. One loan is at 10% annual interest, the other one at 5%, and the first year's interest is $250. Find the amount of each loan. So we're going to use the formula I equals PRT that we've seen before. I'm just going to make a chart to organize my thoughts. I'm going to have the principal times the rate times the time is going to spit out the interest in the last column. So the question is, find the amount of each loan. In other words, the principal, the amount that was pulled out of each loan. I don't know that, so I'm going to call it X and Y. I do know the two different interest rates. One is 10%. I'm going to move the decimal twice and put it as a 0.10. And the 5%, move the decimal twice, and that's 0.05. Again, we're just dividing these guys by 100. Time, it said just the first year, so time must be 1. Now look up, multiply PRT, and that spits out the interest after the first year. So 0.10x times 1 and 0.05y times 1 as well. Now the two other pieces of info that we're going to use are right here that says totaling 4,000, so that was the total principal, and the first year's interest total, we assume for both, was 250. So the total principal is 4,000 and the total interest is 250. That's going to give me my two equations. X plus y is 4,000 and 0.10x plus 0.05y is 250 made. So I'm going to multiply everything through by 100 because I want to get rid of those decimals. Move them twice, multiply by 100. Oops, let's multiply the right side by 100. We forgot to do that. And then for the top one, I'm going to choose to isolate the y because I want to use substitution. Just because I just want to use substitution. I could use elimination if I wanted to, but I decided for practice to use substitution. So I'm going to plug that into the place of the y. So once we plugged it in, we distribute it, combine like terms, isolate x, and we have 1,000 and 3,000. So to go back and answer the question, 1,000 was invested or pulled out of the 10% loan, and 3,000 was the y value, which is the 5% loan. So I guess 1,000 was the 10% interest loan, and 3,000 was the 5% account interest loan, totaling to 4,000. Okay, this is one of those mixture problems, so I'm going to have my jars ready and I'm going to mix them to get a final mixture. It says determine the milliliters of a 10% acid solution and the milliliters of a 25% acid solution. That should be mixed to 20 milliliters, so this guy is going to be 20 milliliters high of an 18% acid solution. Mix these guys up and get an 18% concentration. It says determine the milliliters of this guy and this guy. So I don't know how high this should be. I'll say X milliliters. I don't know how high that should be. Y milliliters. And that's going to give me my two equations. So X is the milliliters of the first, Y is the milliliters of the second, and I do know that total they add up to 20 milliliters, so there's one equation. And also the pure concentration amount, the X milliliters is at 10% concentration, the Y milliliters is at 25% concentration, and the 20 milliliters that's final has an 18% concentration. So there's my second equation that gives me the pure milliliters of this acid. So we multiply the right side, and then I want to get rid of these decimals. So I get my two equations, x plus y is 20 and 10x plus 25y is 360. So once I decide to get rid of the x's, I multiply everybody by -10. X's cancel. I solve for y and I get 10.6666 forever milliliters of the 25% solution because that was what was my y value. And then I plug that into my other equation and get the corresponding x value, which is 9.333 milliliters of the 10% solution.